Hello, everyone. My name is Ian McLaughlin, and I have a PhD in neuroscience. And today, I have a question for you. So I want you to stretch out your palm, stretch out your hand right in front of you, with your palm facing upward, and imagine, visualize a butterfly landing and resting on your palm, with its wings slowly flapping as they sometimes do, and just sit with that for a minute. Close your eyes if you have to. Okay, so on a scale of 1 to 5, how visual of an experience did you have? With 1 being absolutely no visual experience whatsoever, and 5 being as vivid an experience, a visual experience, as if a butterfly were literally landing on your hand right then. And I'd be curious to know where you landed on the 1 to 5 scale in the comments. What did the butterfly look like? Was it blue, like the beautiful blue morpho that I introed with? Or was it one of those adorable little white butterflies? Could you feel the little butterfly legs tickling your palm? So it turns out that people seem to have fairly radical differences in how visual an experience they have when doing that kind of exercise. Hey, Lucia, thanks for joining. A 3, interesting. Hey, Colin, hey from Lincoln. Hello from Philadelphia. And hello from Vancouver. Thank you very much, Christian. Thanks for joining. And I appreciate the award. Eleanor, a 4. Interesting. Okay. Yeah, so just throughout, let me know, because there will be other prompts like that. But so what I want to talk about today is a topic that's been fairly controversial among my scientist friends. It literally led to like a fairly heated debate with a friend of mine who got their PhD in a non-biological field, who thought it all just came down to how we understand the words that we say to each other, which frankly was my initial instinct as well. So what I want to discuss is aphantasia. So that probably sounds like kind of a silly word, and it sort of is a silly word. After all, the term is fairly new. So here is the, no, where are we? Oh, weird. Oh, here we go. Gosh, sorry. So this is the original publication, right? So this term, aphantasia, was proposed by Zeman, Dewar, and Della Sala from the universities in Exeter, as well as Edinburgh in 2015. Edinburgh. And so as they describe it, the term is meant to describe a blind imagination, the inability to conjure visual experiences at will, and importantly, having visual experiences that aren't actually like hitting your eyes. So in other words, we're talking about the capability to have a visual component to your imagination. And there have been studies in the past that have explored the sort of contours of this aspect of our inner experience. But I do think it's fair to say that this was the first major publication to revivify interest in the concept of people having different capabilities to actually have a visual experience when you visualize something or when you're asked to visualize something, right? As well as the innovation was also to come up with a more scrupulous way to interrogate whether this is a genuine example of variability between people's brains and their consciousness. So in that initial publication, the scientists distinguish 2 forms of this kind of a characteristic, okay? Visual memory disorders and, more relevant to aphantasia, imagery generation deficits. Okay, so when it comes to visual memory disorders, we're talking about the loss of visual components of memory, right? And this is something that can happen, after some kind of an insult to the brain, right? Like a stroke or a traumatic brain injury. However, in imagery generation deficits, we're talking about just the inability to conjure imagined visual experiences, right? So in other words, a lack of a visual component to when someone is trying to visualize something. Hey, Georgia, thanks for joining. Hey, Christine. I realized that I have to do this so I don't miss some of your comments on YouTube. Thank you for reminding me. We'll do that. This group, right, published a paper 11 years ago describing this concept. And there might be some kind of a distinction, they focused on if there's some kind of a distinction how it is that people might be able to visualize things, right? And so the famous science writer, Carl Zimmer, wrote about that initial publication. And that's here. Okay, and so this initial publication is a relatively simple one, right? What they're doing in that earlier publication is describing a 65-year-old man who became unable to conjure visual components, who became unable to, via his imagination or his mind's eye after a coronary angioplasty, which is basically just a surgical procedure to widen arteries so blood can flow more effectively through them, right? And so this group, headed up by Dr. Adam Zeman, and he's a neurologist at the University of Exeter, described this finding, and Carl Zimmer wrote about it in the popular press. And so Zeman ended up getting over 20 people contact him, explaining that they found this description of that 65-year-old man's experience as being quite reminiscent of their own. But the big difference was that their inabilities to conjure visual elements to their mind's eye was not associated with any kind of surgery or incident or injury. It had been lifelong. So Zeman set out Zeman and his group set out to interrogate this possibility a little bit more thoroughly. However, they were not the first group to ever stumble on this potential point of variability in our conscious experiences. Sir Francis Galton, an incredibly influential scientist, among other things, polyglot, I suppose, famous for a variety of things, like the study of intelligence, as well as pioneering eugenics, noticed that this phenomenon, might be a thing way back in the 1880s. He didn't have a term for it, but as was the case in many domains of science at the time, Galton was one of the first to come up with a kind of test to evaluate whether something like aphantasia might exist. Hey, Eleonora, good to see you. And thank you, Eleanor. I appreciate that award a lot. Thank you. So Galton came up, his test was called the breakfast table survey, okay? And so here's how it goes. Imagine your breakfast table and rate the illumination, the visual features, the colors, the objects on the table, okay? Way back in the 1880s. So most people in this survey that he conducted responded with having some ability to truly visualize, but he found that there was quite a bit of variability, even back then, with some people reporting things like, quote, thinking of the breakfast table this morning, all the objects in my mental picture are as bright as the actual scene. However, Galton also got responses at the other end of the spectrum. Another quote, it is only by a figure of speech that I can describe my recollection of a scene as a mental image, which I can see with my mind's eye, end quote. So keep in mind, that's back in the 1880s, right? The late 1800s. So Zeman's group set out to explore this phenomenon in greater detail. They came up with a new type of test, what they call the Vividness of Visual Imagery Questionnaire, that they posed to people who reached out to him after that earlier publication about the 65-year-old man who lost his capability to visualize things. And so they explored their visual experience, but they also explored who these people were. And so they asked them questions like, quote, is your lack of visual imagery total, or do you sometimes experience brief flashes of imagery? Another one, is your ability to imagine affected by whether your eyes are open or closed? Are all types of imagery affected? Or can you imagine sounds, including music, textures, like imagine touch, tastes, or smells? Another one, do you dream normally? And in particular, do you see visual images in your dream? So, questions like that. And, this whole time I'm interested in how you respond to these types of prompts, because the prospect that there's quite a bit of variability here is kind of exciting. So clearly, what they were trying to do with those questions is trying to get a sense of who the people were, right? With what their broader experiences were and whether they felt that their inability to conjure mental images. Keep in mind, these are people who reached out to Dr. Zeman saying, I think I was born this way, right? If they felt that, their inability to conjure those mental images influenced things like career decisions, past relationships, and how they remembered their past experiences. So generally speaking, in this study, respondents said that they'd become aware of this unique conscious experience in their teens or their 20s. And it was via interactions with other people or via reading, realizing that most people literally saw things in their mind's eye, whereas they didn't. And so interestingly, while most of the respondents reported that they either had a complete or nearly complete absence of visual components to their efforts to visualize things, there were still visual components to things like dreams. The study also explored things like how this inability to visualize things affected how they approached relationships and things like that. Frankly, I think that study was a bit too small to really rely on those, really rely too heavily on those results. It was a small sample size, but interesting stuff nonetheless. So another interesting blip on the radar of this paper was what seemed to be difficulties with autobiographical memory. So in other words, memories about the self, episodes in one's own life, like their first kiss or their first concert, or the experiences they had at a bar with their friends a few nights ago, like what the bar looked like and what the table looked like, stuff like that. And so it is more complicated than that, autobiographical memory, but that's the main point here. There did seem to be a kind of shared difficulty with autobiographical memory among people reporting themselves as being aphantasiacs. So pretty interesting. So when it came to testing their ability to conjure visual experiences, right, the main point here, Siemens group posed the types of questions that I opened with, right? So on a scale of 1 to 5, 5 being a visual experience that's as vivid as it would be if it were truly happening in reality, right in front of them, they were asked to rate certain experiences. So here are some examples. And yeah, I want you to think about this for yourself. So, quote, visualize a rising sun. Consider carefully the picture that comes before your mind's eye. And then, on a scale of 1 to 5, rate the visual experience of the following. The sun rising above the horizon into a hazy sky. The sky clears and surrounds the sun with blueness. Clouds. A storm blows up with flashes of lightning. A rainbow appears. Right? 1 to 5 on all of those things. I mean, yeah, you don't have to do it for all of those things, but just think about it for yourself. And then another one. Think of a relative whom you frequently see, but is not with you at the present, obviously, and consider carefully the picture that comes before your mind's eye. The exact contour of face, head, shoulders, and body, characteristic poses of the head, attitudes of the body, precise carriage, right? Length of step, walking, these types of things, different colors worn in some familiar clothes. So it's questions like that, right? And so, maybe you can quiz yourself. And of course, they compared their results to a control group, right? People who did not respond by saying, I think I am an aphantasiac. And so here were their results. We can go here. Let's see if this is going to be big enough to see. Yeah, I think that's fine. So VVIQ, which is the, why don't we just do this? VVIQ is the initialism that they use for that questionnaire that they came up with, the vividness of visual imagery questionnaire, which frankly is sort of like a playful, or I guess since they're from the UK, a cheeky initialism, right? VVIQ, like the IQ test, maybe a nod to Sir Francis Galton, I don't know. But anyways, the higher a person's VVIQ score, the more visual their responses were to those questions. And the height of the columns that you're seeing were the number of people who landed on any given point along the VVIQ spectrum. So a higher column means more people ended up with that score. Okay. So you can see that there's a fair bit of variability in the control group, right? That's the bottom panel, right there. Yeah, the bottom panel. And so, the group of people to whom they compared, the people that reached out to Zeman, saying that they thought they might be born with aphantasia. And so you can see that their scores sort of range from about 32 to just under 80, which is the highest possible score, representing uniformly vivid visualizations. And so, you may notice that some of the members of the control group are pretty super high, a minority, but some are almost at 80. So they're a group that the scientists have come to describe as having hyperphantasia. However, along the top, up here, let's see if, yep, you can see that the aphantasiacs all ended up towards the lowest end of that vividness spectrum, with most of them responding with a score of 16, which is the lowest possible VVIQ score, indicating a constant and complete absence of any vivid visualization whatsoever when they were prompted with those questions. So ultimately, after this work, they estimated, and I've seen different numbers, but they've estimated that about 1% of people have aphantasia, while 2.6% of people may have hyperphantasia. 2.6%. It's pretty high when it comes to like population, wide numbers. And so in this paper from 2015, Zeman accepts that this whole phenomenon is worthy of skepticism, and that has very much been my experience when bringing this up with other scientists, even neuroscientists. And as I said, I got into a fairly heated debate about whether something like this could actually even exist, with his instinct, this other scientist's instinct, being that it's really just a poverty of language that's preventing us from really effectively conveying the subtler and more granular details of our inner subjective experiences, rather than being like an actual variability in our subjective experience, right? Encoded in the brain. And so that was absolutely my initial instinct, right? Over the years working on my PhD in neuroscience, I became increasingly convinced of a couple things. So the subtle subjective components of our consciousness, what it's like to see the color red, what it's like to taste a Sichuan peppercorn, which if you've never tasted a Sichuan peppercorn, highly recommend that you do. It's a very strange experience and somewhat addictive from my perspective. I'm going to have some tonight. But anyways, those experiences are firmly grounded in neurophysiological activity. The neurobiological activity is complex, multifaceted, and the science isn't mature enough yet to explain all of it. But those things, sometimes referred to as qualia by our friends in philosophy, our friends who would disagree with me on that point, those things are absolutely explicable neurobiologically. I just became more and more convinced of that over the course of my research. However, it is true, all language suffers from a poverty of precision at a certain point, right? There are only so many words to describe internal experiences, complex states of consciousness. And so we end up bucketing a whole spectrum of emotional, sensory, cognitive experiences into sort of general categories by default. We have words like happiness, contentedness, satisfaction, joy, euphoria, elation, jubilance, right? And so on, all of which describe certain constellations of neurobiological activity in a given moment, right? That are slightly different, those constellations, but closely related, and they do overlap a bit. And so, they're all generally positive emotional states. But when it comes to even more abstract aspects of our conscious experience, we suffer from an even greater poverty of language. And so, hey, Christy, hey, Colin, a huge percentage of people believe that the ability to see something in the mind's eye should be in full technicolor. Hey, Christy. And so, Christian, can one lose the ability to imagine with a stroke? Absolutely. And then Christian says, poetry completely relies on the ability to see things through the mind's eye. Exactly. That's sort of, that's sort of what I'm getting to, right? And so, so we suffer, even the most gifted poets, right, and writers, we suffer from this poverty of language at a certain point. There just aren't that many ways to describe the exercise of visualizing something, right, nor the visual experience that people have when they're doing it. So when I ask you to visualize that butterfly, right, on your palm, maybe your experience is actually quite similar to mine, but you're just deciding that this experience qualifies as a visual experience, whereas I'm a little bit more stringent, right? And I consider it to be completely devoid of any visual component, which is my experience. And so when it comes to, all the words that we have, even for positive emotional states, there's just no way that we could come up with enough words to distinguish all of the possible combinations of neuronal activities throughout the brain that encode all of the subtle variations in emotional states moment to moment. And so, in other words, there's most certainly aspects of our consciousness that are lost in translation, right, when we're trying to express them verbally, which I imagine is part of why art, music, movies, poetry are such critical media by which those subtler aspects of consciousness can be conveyed or portrayed, right? Just one word or even a set of words isn't enough to convey those subtle aspects of our experiences. But we also know, without a doubt, that the brain is a venue of tremendous variability and diversity. And so the brains of siblings, even identical twins, will be different at a certain level, right, anatomically. And so people have, different capabilities and predispositions to various psychiatric conditions or addiction. That was one of the fundamental motivations of the research I did for my PhD. And so the prospect that people also vary according to how it is that their minds produce visual imagery definitely doesn't strike me as all that far-fetched, right? Oh, thank you very much, Carrie. I really appreciate that award. And so Colin says, oh, and hey from LA, awesome. And so Colin says, when asked to visualize, for me, it can be more of a knowing rather than a clear visual. All the aspects and components of the vision are there, though, even down to the color and clothing, body language. Right. So that's where it becomes a little bit difficult. So you're saying that all the visual components are there. The visual components are there, but you describe it as a knowing rather than vision. So somebody who would respond with a 5, and I've had conversations with people who respond with a 5, and I pester them. I'm like, okay, a 5 means that like there might as well be a butterfly in your hand, right? Like you might as well literally be looking at a butterfly that literally landed on your palm. They'll be like, yeah, it's a 5. Neuroscientists will have just one that would respond that way. And for me, that's like, how is that not like just hallucination, right? If I was like literally seeing something that I was imagining, I would be worried that I was dosed with something. And I would love to see a study conducted on, these hyperphantasiacs, right? So that kind of a person would be rated as a hyperphantasiac by Dr. Zeman, the scientist who really, resumed interest in aphantasia. I would love to see if they respond differently to hallucinogenic substances. Topic for another day. So we have this variability in the brain. Some people have incredible memories, incredible abilities to recall various features of past experiences, or they can do things like list the numbers of pi with outrageous precision, right? Whereas others struggle with remembering what they had for breakfast just a few hours ago. And so why wouldn't that kind of diversity pervade into something like visualization? Okay, wait, we have more comments. And so Christian says, at the same time, words can express abstract things we cannot see or imagine, which is actually amazing. Totally. Yeah, a critical component of human evolution. And so there are some activities that develop some areas of the brain that might help that, indeed. You mean like exercises? Hey, what's up, Brett? Thanks for joining, man. And so Lucia says, me as an architect. Oh, I didn't know that. Cool. We use a lot that visual part of our imagination, graphic memory. It's easier for me to visualize something like an image. Interesting. Eleanor says, I would love to see that as well. Okay, who's dosing me? And then Christian says, this raises an interesting question of witnessing events where we change facts after time. So what is real? Definitely, right? Okay, so Zeman and company in 2015, right, suggest that the frequency of congenital aphantasia, as I said before, in other words, being born with the inability to voluntarily form mental imagery is I've seen him give different like statistics. Basically, it's always between 1% and 2% of people, right? And so they also found that there seems to be a spectrum among people who qualify as having aphantasia, right? With some people being able to have visual components of things like their memories, while others have zero visual components to their memory whatsoever, right? It's just remembering the facts, right? And not the actual sensory visual experiences. Okay, so what's happened since those surveys that Dr. Zeman conducted in 2015, right, where he coined the term congenital aphantasia? So a study was published by a different group in March of 2021. And here is that, in case you want to check it out. So just a few months ago, right, that adds a little bit more science for understanding of what might be going on in the brains of people with and without aphantasia when trying to conjure mental images. It's a little bit not directly related, but it definitely helps. So this group, headed up by Dr. Joel Pearson at the University of New South Wales in Australia, came up with what I would argue is a more objective test than just a set of survey questions. And so they were operating with the hypothesis that mental imagery occurs, right, that the capability evolved to link thoughts with emotional responses, and that the sensory experiences that we have when conjuring mental imagery are mostly involuntary for the majority of people, for people who wouldn't be considered as having aphantasia. And so here's what they did. So Pearson and his colleagues, they used the same VVIQ, right, the vividness of visual imagery questionnaire test, right, that Dr. Zeman used in 2015, when they, in that article in 2015, when they coined congenital aphantasia. And they were comparing a group of aphantasiacs to a control group. But they also measured a few physiological responses among their study participants. And they focused on imagery. They were prompting their participants with imagery that would be expected to elicit a fearful or stressful response. And so what they did is they measured skin conductance levels. And that's also known as galvanic skin response, which you can think of sort of as like how hot and sweaty people become, right? So for example, you walk into a room and you're surprised by seeing a giant spider or a snake or something, right? Your skin conductance will go up. You get a sort of hot and sweaty reaction because your fight or flight response, your sympathetic nervous system, becomes rapidly activated. And it's preparing you for a fight or flee, situation, right? Or a situation that may jeopardize your survival. And so importantly, those responses are entirely beyond your control. You can't just decide to elevate your skin conductance level. It just happens as a function of your emotional reactions to the things around you. So it's kind of a convenient way to measure what someone's internal emotional state is like without having to rely on them just telling you what it's like, right? It's more objective than self-reporting. And so Dr. Pearson and his colleagues had their participants go through two processes intended to elicit a kind of fearful, stressful response, okay? One of them just involved imagining scenarios. The other involved them just looking at pictures. So one would challenge participants to visualize a freaky scenario, while the other was just a straight up, overt, real world visual experience. So in the process where participants imagined freaky scenarios, what they did is they read a series of first-person fictional scenarios intended to evoke this fearful, stressful response. And the scientists were measuring their skin conductance levels continuously, how hot and sweaty they were becoming over time. And we know that skin conductance levels will increase when people experience stress or fear, right? Very well established at this point. And that includes when people are just imagining stressful or fearful experiences. And so the scenarios where participants were confronted, or with which participants were confronted, were also intentionally visually provocative and vividly described. And so the group's hypothesis was that aphantasiacs would exhibit much lower skin conductance levels in response to those visually provocative, fearful scenarios compared to controls, due to the assumption that the absence of the ability to have a visual component of their reactions to fearful, scenarios. And so in other words, aphantasiacs just, wouldn't get as hot and sweaty, right? Because they weren't really seeing anything. So meditation. Oh, thanks, Mark. I appreciate you stopping by. I appreciate the award. And so Colin brings up, I've meditated in the past and experienced seeing the imagery in full flow with 100% clarity, almost as if watching a scene on a TV. The imagery seems to be cleaner when it is allowed to occur rather than trying to create an image or vision intentionally. That's super interesting. I've thought about meditation a lot in this, in relation to this topic. I took a class in mindfulness meditation, and there's different sort of camps of mindfulness meditation. There's transcendental meditation, which is a little bit more of a formal kind of thing. And then there's just sort of mindfulness meditation more broadly. And that's what I did. And some of the strategies to get people, it's very, very difficult to do mindfulness meditation. At least it certainly was for me. And so one of the strategies that instructors can use is guided visual meditation, where they ask you to imagine you're sitting in, an ice cave or something like that, right? Something that would enable you to encompass a lot of your sensory processes and really focus on that rather than the sort of parade of thoughts that you can't control, which is kind of the whole purpose of mindfulness meditation. And I thought about that. And I think that would be an interesting venue to explore aphantasia, because I would argue that that is an altered state of consciousness once you become good at it, right? It's not like you're just sitting there sober if you're in a state of mindfulness. And so it could be the case that people who aren't at the lowest end of the aphantasia spectrum, just a little bit higher, they might be able in that altered state of consciousness to conjure mental imagery, whereas in the absence of that kind of altered state, they can't, right? So yeah, interesting thought. So Georgia says, is this related to why, oh, and by the way, Georgia is a PhD candidate, and she studies evolutionary biology, and she's been joining the HAPS community talking about really interesting topics. Most recently, we talked about science fiction with other scientists. So everybody should check out Georgia's channel. And so, yes, okay. So in addition to those fearfully provocative scenarios, right, where participants were asked to imagine and therefore visualize, the group also exposed, participants to just straight up pictures intended to elicit a fearful response. So that was the second process. So in this case, there would be zero need for someone, to conjure a visual experience. So just literally looking at freaky pictures of snakes and stuff. And so before starting either process, scientists collected each person's baseline, right? Before they either imagined a freaky scenario or looked at freaky pictures, and then they started the process. Okay, and so here were their results. Where did I put it? Ah, here it is. Let's do that. Okay, so what do you see? Okay, well, along the bottom, that bottom group, I realize I just pointed to it with my mouse, which you cannot see, but the bottom, you have, how two groups of people, the aphantasiacs and the control group, respond to just seeing straight up freaky pictures of snakes and stuff. And so you see how their skin conductance, the measure of how hot and sweaty they got over time, with the aphantasiacs in blue and the control group in red. Personally, I would have reversed those colors, but no big deal. And so as you can see, they responded pretty much identically, right? No big difference. The pictures freaked them out almost identically, right? The lines are essentially overlapping. However, along the top, in that top panel, you can see that those lines diverge pretty substantially, right? They don't overlap at all, pretty much. And so those are their responses to just being prompted with written scenarios intended to be visually provocative and freaky. And so, you can see that the control group, the red line, got pretty hot and sweaty over time. But the aphantasiacs were cool as cucumbers, right? They were cool customers. Essentially no hot and sweaty response whatsoever. They might as well just be reading a dictionary, right? And the bar graphs next to the line graphs are just there to drive home the point that these two groups had basically identical reactions to seeing just straight up pictures, while they had pretty substantially different responses to reading visually provocative scenarios. So super cool, right? Even the part of the nervous system that's regulated almost entirely by unconscious processes that you can't just decide to activate responds differently when someone has to rely on imagining experience if they're unable to have a visual component to that imagined experience. Okay, so this seems like it might be a real thing. So one of the most important questions that neuroscientists can answer about how it is that the brain encodes various aspects of our conscious experience is, what is that thing's neural correlate or brain correlate? Meaning, what is it that happens in the brain when a given aspect of our conscious experience occurs, right? What happens in the brain when you smell a rose or snuggle with the person you love, right? Or suffer a calamitous loss of a person you love. So in other words, how is the brain producing this aspect of consciousness? And so Dr. Pearson's team at the University of New South Wales in Australia has done even more work that helps us get closer to a neural correlate of aphantasia. Okay, they've helped us to uncover whether there is or isn't anything different going on in the brain of somebody who claims to be an aphantasiac relative to someone who doesn't. Okay, and so here is that article. Do that. So this article is open source, by the way, so you can just read it without a subscription. And I will try and remember to link the papers in the comment section. So the group notes that in this paper that studies have found neural correlates of how vivid, right, visual experiences can be in the visual cortex. The more vivid a visual experience is, the greater the response seems to be in the visual cortex, which is sort of this area right in the back of the brain. And then so also studies working with people who have synesthesia. Okay, a condition where people can have like incorrect or crossed sensory experiences, have found neural correlates in the same region of the brain, the visual cortex. So in other words, when somebody looks at, let's say letters or numbers on a page, a synesthesiac, or somebody with synesthesia, can have the experience of colors, despite there being no colors to be experienced there, right? If they look at the letter S in black ink, right, they can have a sort of purplish reaction. And if they look at the number 5, black ink on white paper, they have a sort of yellowish experience. I mean, it varies between different people, but that is sort of what we're talking about with this form of synesthesia. And so it turns out that studies have found that there's measurable activity in the visual cortex, again, towards the back of the brain. When people with that kind of synesthesia, that's called grapheme color, right? When you look at like a letter or a number and you have a sort of color experience despite there being no color. So, there's a measurable event in the brain when they have those color experiences in response to certain letters or numbers, okay? So there are neural correlates of some of the more, let's say, exotic manifestations of visual experiences. But the reason they did this study was that until then, no studies had explored why it might be that some people seem to more effectively conjure vivid visual experiences than others. So they used a whole variety of neuroimaging techniques, think like fMRI, functional magnetic resonance imaging, to see if there might be some inherent differences in parts of the brain that process vision between people with and without aphantasia. All right, okay. So it's not really worth getting into how they conducted this study in particular, because it's a whole mishmash of like behavioral and imaging techniques. But what they found was, here we go, and we can get rid of that. And why don't we do this? Okay, so here's what they found. That people who have lower excitability in the visual cortex, way back here, tended to be better able to conjure visual experiences. Okay, and you can see that in this figure here. So if you just take a look at the bottom cartoon brains, the ones that are mostly just shades of gray with some little blue areas, what they're showing are areas of the brain that seem to be less active when they're just sort of hanging out, when they're just resting, in other words, not focused on anything. So where it's blue, those are areas of the brain that tended to have lower activity. And so what they're showing is that when it came to the intensity or vividness of a specific kind of visual experience, people who had more vivid experiences tended to have lower resting excitability in the visual cortex, okay? And so interestingly, higher excitability in the frontal cortex, which you can sort of see in that like sort of reddish areas of the frontal regions of the cartoon brains on the top. So the team found a possible neural correlate, a certain pattern of brain activity that's associated with visual vividness specifically. So of course the question is, can this help us to understand if there might be some involvement of those brain regions in what distinguishes people's ability to conjure mental images? These data suggest that there at least seems to be innate differences in how various brain regions involved in the vividness of an image differs between people, right? Innate, architectural, right? Just anatomical. And so perhaps it's a difference in how much activity in those two brain regions in particular, the visual cortex, no surprise there, and the frontal cortex, that results in varying abilities to conjure mental images, right? Okay, so Joji says, is this related to why people are more worried about a shark attack versus a vending machine falling on them? The shark is easier to imagine, but you're more likely to die by a vending machine. Yeah, I love that comparison. I would imagine it's part of it. I mean, I think that that would involve a lot more novelty. That you see not so much anymore, I guess. Maybe you do. I don't know. You see vending machines all the time, whereas you rarely ever see a shark unless you're like a shark scientist or swimming with sharks, scuba diving or something like that, which I did. I have a crazy shark story. But anyway, so Lucia says, well, people after watching Jaws, you could sing the theme song while on the beach and maybe half the group would get out of the water. Exactly. Yeah, what a brilliant theme song, huh? They also see sound. Yeah, so different, I assume Bo is referring to people with synesthesia. Yeah, so there's many different forms of synesthesia. Perhaps one of I think one of the lesser known but really intriguing forms of synesthesia is mirror touch synesthesia, where if somebody with this form observes something happening to another person, like let's say getting punched in the gut, right, getting the wind knocked out of them, they can closer to literally have that experience than just be like, ooh, that looks nasty. Like we all have a dose of that, right? We all are able, well, not all of us, but the majority of us are capable of empathizing with the experiences of others, which is why it can be disturbing to observe somebody suffering. Not for everybody. Some folks don't have that kind of empathetic response, but for folks with this form of synesthesia, right, it's even more profound, and that there's a whole spectrum of how significantly people respond that way. But yeah, there's a bunch. So growing up, my friend's dad was a composer, really cool job, right? And he was kind of a strange dude, not gonna lie, but he had a form of synesthesia, the one that you're referring to, where color sounds would evoke colors, color visual experience. Which sounds like a superpower to me. And imagine being a conductor. You're like essentially painting with sound. Really cool. But it was also, it could be a little bit debilitating. Like he had to like be very careful when driving, had to be silent and like things like that. So it is a super interesting topic. Definitely a topic I'm going to talk about in greater depth in the future, because we've learned a lot more about synesthesia. And so Eleanor says, my son has that he tastes and sees color with music. Huh. Very interesting. But people see shark attacks in movies more. Yeah, indeed, right. Hello from Amsterdam. Hello, Helga. Thank you for joining. Okay, so Dr. Siemens' group, right, the scientists who first coined the term congenital aphantasia, right, whom we discussed in the very beginning, right, came out with a paper in January of this year that explores just that question of, are there neural correlates that distinguish people with aphantasia from people who do not have it, right? And I have to be honest, I don't like the way this article is written, but that's not really that important. Let's see, where are you? I know I have it. Here we go. Okay. So that's the paper, and yeah, it's not written perfectly. I think they could use an editor, but in any case, they did a lot of experiments in this study. Right, so let's just focus on the crux of their findings, okay? So first of all, they're working with 69 people this time, more rather than just 21, who fell into 3 categories, okay? People with aphantasia, people with normal imagery vividness, and people with hyperphantasia, okay? And so the goal was to see if there was something different about patterns of brain activity in people with normal visualization capabilities, as well as people with unusually vivid, usually high visualization capabilities, hyperphantasia, relative to people with aphantasia. Okay, so first of all, a small part of the work in this study that the group did was essentially what the other group in Australia, headed up by Dr. Pearson, did, right? And came to very similar results. People with hyperphantasia appear to have greater connectivity between frontal regions of the brain and posterior regions of the brain, towards the back of the brain, right? And so the results were reproduced by 2 separate groups. Always good to see it in science. And so Angus says, I just experienced an episode of synesthesia I recently experienced since TJ has been, in which my cat heard a noise from my, I did not mean to post that, was posted a mix of pocket text. I see, okay, gotcha. Hey from Long Island, hey Marcia, or Marcia maybe. Okay, so three separate groups, right? And they reproduced the results sort of indirectly, but reproduced the results from the group in Australia. Great to see. Beyond that, and again, they did a bunch more than I'm going to discuss, but this figure sort of encapsulates their main argument. So here we go here, and then I'll just get rid of the article title, and then let's just focus on this a little bit. So you're basically looking at collective brains, okay? So it's like if somebody were to scan my brain, George's brain, Christian's brain, Helga's brain, right? My neighbor's brains, and and so on, and then put them all together into one brain, okay? And so this is the brain activity that they measured when people were asked to do something like imagine an apple, right? What color is the apple? What size is it? Is the apple shiny or is it rough? Those types of questions. And so on the left side, you are seeing a comparison of how the brains of people who have aphantasia compare to those with hyperphantasia. And on the right side, and you'll have to excuse me if things get flipped, but yeah, it has those little titles underneath. So, but you're seeing aphantasiacs brains compared to control or normal brains, right? The brains of people who would fall in the middle of that, VVIQ, that visualization vividness scale. And so the little red splotches are areas that were activated more in the brains of either hyperphantasiacs or in control brains relative to aphantasiacs. And so, in both cases, you're seeing some measurable differences. So another way to think about it would be like that the neurons in those parts of the brain that are marked with red splotches seem to be less active in people with aphantasia when compared to people who have just sort of like average visualization capabilities, the controls, as well as people who have unusually vivid visualization capabilities, hyperphantasiacs. So what's interesting though, is if you just qualitatively, you don't need to like draw any lines or anything, but if you compare the areas between the two, right? If you look at the areas that were more active in the normal brains, pretty much every single one is also more active in the brains of people with hyperphantasia, who have unusually vivid imagined visualizations. But there do seem to be some additional areas that are unusually active in the brains, or maybe uniquely active in the brains of people with hyperphantasia. And even in the areas that are more active in both control and hyperphantasiacs, the areas that they both share as being more active relative to aphantasiacs, the areas seem to be a bit larger in folks with hyperphantasia, suggesting that perhaps more neurons in those regions were recruited, right, when visualizing. Okay, so we have a measurable difference between people who are completely incapable of conjuring mental images, people who are just sort of the norm, of conjuring mental images, and people who conjure unusually visual, right, vivid mental images. So vivid, keep in mind that it might as well be looking at the real thing. That if I were to ask them to imagine butterflies landing on their outstretched palm, then there might as well literally be a butterfly landing on their palms. Okay, and so so the group also found, which is kind of provocative, that people with aphantasia tended to gravitate towards certain professions, namely those involving science or math. So for example, Craig Venter, the person who was responsible for leading, the team that first mapped out the human genome, very brilliant, very influential, one of the most influential scientists of our time. He claims to be an aphantasiac. And he further claims that it likely helped him to eliminate distractions. Ed Catmull, I don't know if that's how you pronounce his last name, but he's the former president of Pixar, right? The group that puts out animated movies like Brave, A Bug's Life, The Incredibles, Toy Story, Finding Nemo, and some of the loveliest, most treasured and successful animated storytelling of our time. He announced that he is also an aphantasiac. And so if you're like me, okay, and you're a 1, or might as well just be a 0 on the scale of how vividly you literally see the butterfly on your palm, we're in pretty good company. And so beyond that, Dr. Zeman, right, the scientist who coined the term aphantasia, he claims that aphantasiacs also may be better able to move on from tragedies or trauma. So here's a quote, anecdotally, they're really good at moving on. One wonders whether that's because they're less troubled by the kinds of images which, for many of us, come to mind and give rise to regret and longing. And there are interviews that have been done of people who identify, who believe that they are aphantasiacs, where they're sort of disturbed that they lose a parent or a family member, somebody that they love, and they just don't seem to be grieving in the same way that everybody around them is grieving. They feel like there's something wrong with them. And so, Dr. Zeman interviewed some of these folks. It's interesting to read. And so Mad Cow, oh yeah, awesome. Good to see you here, man. Mad Cow says, that's interesting. I always thought my visualizations were just a side effect of photographic memory. I think that is a really interesting potential avenue to explore, is eidactic memory or photographic memory. And it would be interesting to explore whether you can have somebody with a photographic memory, and that's a controversial topic in neuroscience, whether or not it actually exists, but let's just stipulate that it does for the purposes of this conversation, whether they can conjure very vividly visual components of memory, right? Like words on a page, which one of my friends in high school was able to do, very frustrating. But can they conjure visual images without any memory, right? Just like, can they see the butterfly on their palm, right? It would be interesting to explore that potential diversity. So I am generally curious to hear about your experiences when trying to visualize things. Like, I've asked almost everyone around me, I've bugged them, about how they'd rate their visual experiences when imagining the butterfly landing on their palms, including some of the most senior neuroscientists at the University of Pennsylvania, literally the chair of the Department of Neuroscience, as well as, rising graduate school students. I was in grad school at the time, and then current PhDs, like postdocs. These are people studying the brain, in some cases, sensory systems within the brain. And I got a wide range of responses, everything from 1 or 0 to a 4 or a 5. Okay. And so I have to note that something that I don't love about this current conversation about aphantasia is the kind of like medicalization of aphantasia, right? The suggestion that it's a condition. From what I've seen, see what I did there? It strikes me as more of a description of one end of the spectrum of neurophysiological diversity. And, so many of the features of our conscious experience land along a spectrum of predispositions and tendencies that, from my perspective, this really shouldn't be thought of as like a particularly unique condition, right? That would, that almost demands treatment, right? Rather, people who qualify as being an aphantasiac just happen to approach the world with a visual system that's just more directly based in what's literally stimulating the photoreceptors of their eyes, right? If the photoreceptors of the eyes aren't being stimulated, they're just not going to be a visual experience. So that's what I have for you today. Oh, I should also note that there's an online community focused on aphantasia right here. I guess I can make it bigger for a sec. That you might want to check out if you're interested in exploring some of the broader conversations about it. They have interviews with Dr. Zeman and Dr. Pearson, the two leads of the scientific groups that explored aphantasia. There's conversations between people who are trying to understand if they would qualify as an aphantasiac. And online discussion was critical to the sort of rise in interest in aphantasia, almost reminiscent of what happened with misophonia, where people interacting with each other online were what led to scientists taking it a little bit more seriously. And so, the link to the aphantasia community is in that image, but it's just aphantasia.com, right? So not that difficult to get there. So anyways, if you dig exploring the brain and consciousness, maybe you'll consider subscribing and liking and doing all that kind of stuff wherever you're watching. Otherwise, I will see you next week. And if you have any comments left, let's chat. Hey, Pablo, good to see you, man. Thanks for joining. I have felt like that with every death I've faced, but then other traumatic events have left me with agoraphobia. Oh, so Eleanor, are you comparing yourself where you don't seem to grieve to the same, or your grieving isn't at the same magnitude, right, of the people around you? Yeah, so for anybody that is just joining, there has been this possibility that people with aphantasia seem to be able to move on from traumatic experiences a little bit more efficiently, right? A little bit more rapidly than people who don't. And there have been interviews with people who would qualify as having aphantasia who are disturbed by that. They don't grieve as much as the people around them, like when they lose a parent or something like that. It's sort of disturbing to them that they're not experiencing that emotional effect. And so I think most things are on a spectrum. Your instincts are correct. I saw your pre-broadcast post, so I Googled, and there are tests online. I scored hyperphantasia. Awesome. Sometimes my synesthesia is brought out and experienced more vividly than others. Is this a self-perceived phenomenon, or what is it that I'm doing that brings out this experience and makes it? Well, so yeah, I mean, so like the things that trigger synesthetic experiences, that's super complicated, and I don't know that we actually have like a solid answer. But here's what I would speculate is the explanation. So we're still figuring out like what is the neuroanatomy of synesthesia, right? A couple different theories. Probably the most compelling theory at this point is that there is unusual connectivity between parts of the brain that process the sensory systems that in somebody without synesthesia are distinct, right? They don't really talk directly to each other. And so as a result, what happens, let's just go with grapheme color, right? Meaning somebody with synesthesia where they look at a letter, let's say just the letter 5, print from a printer, a big letter 5 printed on a white paper, they experience a sort of yellowish hue around it, right? And so one of the theories is that for one reason or another, and that's a whole different bucket of questions, when the parts of the brain that are activated in all of us, when we're understanding, looking at, and deciphering a character like 5, right, a symbol, then those neurons send the information, to the standard regions of the brain that process, language and vision and stuff like that, right? Higher level visual processing, but then also directly send signals to another part of the brain that processes color vision, right? Specifically color vision. And so you get this sort of like boom, boom, activation, whereas in somebody who doesn't have that anatomy, you don't get that subsequent activation. And that would be applicable to other forms of synesthesia as well. Like lexical gustatory is an interesting one, where certain words elicit a gustatory response, like a flavory kind of response. And so language processing, I say the word I don't know, it's cactus, right? And somebody experiences a sort of spicy kind of like they just ate some hot sauce or something like that experience. Same kind of process, right? The auditory system is taking in the word cactus, right? And then sending, the language processing comprehension parts of the brain are understanding, cactus. Perhaps you're visualizing a cactus if you don't have aphantasia. But then those neurons also send signals to, olfactory processes, right? Or specifically gustatory, right? But and so you have that kind of that crossed process. And so what is it that triggers this? Theoretically, it would just be if anything happens to trigger those neurons that have that unique connectivity, if that's a trigger, right? And then you have those experiences. But I don't know that we have a solid answer for that. Thank you very much, Janice. I appreciate the award. And so I really felt that with the loss of my wife, I feel like I should have been much more of a wreck. I see. Or others keep telling me I should, and I've worried I've dissociated from it. At the same time, I know I haven't. Yeah, I mean, grieving is, everybody processes. I'm sorry to hear that you lost your wife. That's terrible. Grieving there's a diversity in how people grieve. There's also a diversity in people's predispositions to depression and post-traumatic stress disorder. Really interesting topic, right? There is there are data that suggest that there is a genetic component to how resilient somebody is to depression or PTSD versus how vulnerable they are. And so, this has been studied in soldiers returning from battlefield situations, right, where you have a group, company, a battalion that I'm not fluent in military terminology if you can't tell, but a group of soldiers who all experience the same highly traumatic experience, right? And there's plenty to experience that's traumatic, but only some of them return with PTSD or depression. Obviously, this is extraordinarily complicated past life experience, but there's a gigantic role in this. Also, the environment to which they're returning, right? How much social support, how much they're surrounded by love and support, and versus adversaries, an adversarial environment. All of that plays a role. But there have also been studies that identify certain polymorphism, certain forms of genes that seem to predict whether or not somebody is likely to develop PTSD or depression. And that is almost certainly operative here, right? Where people respond to a traumatic experience like the loss of one of your closest loved ones you're going to respond differently for a whole variety of reasons. But then, I think it is also totally legitimate to, one of the things that people do is suppress those reactions, which they can be then sublimated into addiction or violent, aggressive behavior or things like that. So it is such a complicated topic. But I think it is also legit to recognize that not everybody grieves in the same ways. And it doesn't indicate that you didn't love that person, or that you aren't affected by that person's loss. Yeah, it's an interesting topic. I mean, it's interesting also for me because some people who have come to the whole aphantasia conversation have come to it because of that, not because they recognize that they had deficits in visualization, rather that they've just felt unique in this way. And then lo and behold, they finally stumble on this whole conversation about aphantasia, which is really interesting. And so I feel I'm just very accepting of death. Yeah, of course, that's another possibility, right? Where, that's past life experience. That's what I mean by that, right? Where if somebody's just regularly being exposed to violence or loss like that, right? If many of one's friends have passed away, the next one isn't going to have that novelty and shock, right? They'll want to induce that, and so yeah, I think that there's certainly something to that. Okay, yeah. Yeah. Okay. Well, thank you all for joining. I really appreciate it. And again, if you enjoy these kinds of conversations, maybe you'll consider subscribing wherever you're watching, and liking and pressing all those buttons that indicate good job. I appreciate that, and I appreciate the awards and everything. And I hope you all have a wonderful beginning of your week, and I will see you